Two questions on practice set, question set number 21. Number one says an object is 2 meters tall and is located 7 meters in front of a concave mirror that has a focal length of 3 meters. Okay, this is important right now to identify this concave mirror as either converging or diverging. We like to see the terms converging and diverging, right? Because it tells us right away whether you've got a positive focal length or a negative focal length. Okay, in this case, they don't tell me that directly, but indirectly they do, because we know that a concave mirror is it converging or diverging? It's converging. It's a converging mirror. So that makes the focal length positive. Now, the good news is with this question, if you forget to identify whether it's converging or diverging, you're going to get away with it because it's positive, right? But if it happened to be a convex mirror, you'd have to make sure that you recognize that it was a diverging mirror and therefore a negative focal length. We want to find the size and the orientation of the image. The orientation meaning right side up, upside down. Let's write down some givens here. We've got an object height, HO, is 2.0 meters. We've got a DO of 7.0 meters. We're going to make both of those positive. DO will always be positive for us. HO will pretty much always be positive for us. Okay, we're going to assume the object at least is right side up. My focal length is 3 meters, and it's positive. We've already identified that. We want to find the size of the image, so we're going to find HI here. We're going to find HI, and then we'll worry about the orientation, the right side up or upside down, in a moment here once we calculate that. Probably going to say, what do you want to try first? We only have two equations here, right? Bruce, what do you want to try first? Solve for DI using the 1 over F equation. 1 over F is equal to 1 over DO plus 1 over DI. Okay, if you try this equation, you're never wrong. Right? The worst case scenario is you're not able to get what you're looking for and you use the other one, the magnification equation. Let's try this. 1 over 3 is equal to 1 over 7 plus 1 over DI. And then let's pull out the calculator, do the little trick here. The little trick that we know. We're going to say 1 over 3 minus 1 over 7, because the 1 over 7 goes over by subtracting. This is what I get. Flip that over, and I get DI is equal to 5.25. 5.25 centimeters. Now what do you want to try? It's not what I'm looking for, but odds are it's going to be helpful to me, right? Brandon, what do you want to try next? Good, that's what I would do too. If we're wrong, it's not a big deal because it's a valid equation. We're not going to get the wrong answer, as long as we don't make a mistake with signs or something like that. HI is what I'm looking for. HO is, I got that, 2.0. Negative DI is negative 5.25. Uh-oh. Hold on for a sec. No, I'm good. I just saw the meters here. I saw the meters in this one and this one, and it kind of jumped out at me because, like, well, we usually use centimeters, right? As long as we're using meters throughout it, though, is that okay? Sure it is, right? Doesn't matter what units we're using as long as we're consistent there. So we're good here. DO is 7 meters. So we're going to say on our calculators here, 5.25, negative 5.25 that is, divided by 7, times it by 2, gives me an image height of negative 1.5. So what do we got here? Well, the answer is either going to be C or D. Okay, right side up or upside down. Right side up. Upside down, so it's going to be inverted here. 1.5 meters and inverted. And we know that it's upside down because of the negative image height, right? Negative image height. Make sense? Now, the other thing is you could have recognized as well is that this DI tells me that I have a real image, right? And a real image, if you remember the patterns, a real image is always inverted. And a real image is always inverted, or virtual image is always right side up. Whether we're talking about curved lenses or curved mirrors, it doesn't matter. All right, take a look at the second one. It says when a girl who's 122 centimeters tall stands 40 centimeters in front of a particular mirror, her virtual image in the mirror is upright and 54 centimeters tall. What type of mirror is it? And where is the image distance? Where is the image formed here? We're going to say HO is 122. We're going to say DO is 40 centimeters. This is where she stands. The object is. The image height says it's upright and 54 centimeters tall. So it's positive 54 centimeters here. We want to know what type of mirror it is, and we want to find the value of DI. Any suggestions here? What do you want to try first? HI over HO equals negative DI over DO? Sure. Let's try to solve for DI that way. If it doesn't work for us, then that's okay. We'll just try the other equation. HI over HO equals negative DI over DO. HI is 54 divided by 122 equals negative DI over 40. Okay, let's calculate that now. Say 54 times 40 divided by 122, or I could have said 54 divided by 122 equals times 40, either one, 17.7. So DI is negative 17.7 or negative 18 centimeters, right? Negative 18 centimeters because negative DI equals 18, DI equals negative 18. And if my image, let me see here. That means the answer is either going to be A or C, right? How do we know whether it's convex or concave? Converging or diverging? Yeah?
What I did was I just saw that it was small, virtual, and upright. So
Okay.
Immediately
Well, okay. Fair enough. Convex. Okay. Or diverging. Yeah. A diverging mirror, if you remember the patterns, a diverging mirror always produces a smaller, virtual, and upright image. And this is smaller, virtual, and upright. So then it must be a diverging mirror or a convex mirror. So Thomas, you're right. It does have to be A. If you remember the patterns, that's great. If you don't remember the patterns, there is another way to determine this. I would say at this point you could calculate the focal length. And when you do that, I don't know what the focal length works out to be, but it will be negative something, right? It's going to work out to be negative something. And when you get negative something for a focal length, it tells you that you have a virtual focal point. And the only time we have a virtual focal point is with a diverging lens or mirror. So it's got to be A. Either way you look at it, it's got to be A, convex. Okay, how many people got 2 out of 2 on that? Okay. That was a little tricky. Hey, how many people made a mistake on the convex versus concave there? Okay, a couple people. Yeah, I think that was a little bit tricky, okay? We remember the patterns? Great. If we don't remember the patterns, then we have to solve for something else. Usually when we solve one of these problems, whatever we get the first time tells us the characteristic or the attribute that we're looking for. This time we had to do something else. Either remember the ray diagram, the patterns, or solve for the focal length.